He kōna ipurangi tēnei nā te reo irirangi o Aotearoa.
Kia ora, and welcome to Elemental, an RNZ podcast celebrating the International Year of the Periodic Table. I'm Allan Blackman from Auckland University of Technology.
And I'm Alison Ballance from RNZ, and I am looking forward to this episode of Elemental, celebrating a couple of pioneering women chemists and the elements named in their honour.
And those two pioneering women are Marie Curie and Lise Meitner. And they were indeed pioneers in both chemistry and nuclear physics as well.
Now that raises an interesting point, because I keep saying this is a chemistry podcast, but lots of these elements are actually found by nuclear physicists, aren't they?
Well, the division between chemistry and physics, I guess, in places is very, very fine. And none other than the great Ernest Rutherford classed himself as being a physicist, and then he ended up winning the Nobel Prize in chemistry. And he said of that something like that the fastest transformation in nature that he knew of was his transformation from a physicist to a chemist.
Love it.
But you're right. I mean, the boundary is very, very blurred. It really is. There's a branch of chemistry called physical chemistry, and there's a branch of physics called chemical physics. So where is the join, I guess, is the question.
Now tell me a bit more about Marie and Lisa, or Lisa?
Lise, I guess, the
Lise.
German. Yeah. So obviously we're talking over 100 years ago, and science was very male-dominated in those times, still is. Hierarchical, still is. Sexist, yep. And in all sorts of ways, it was difficult for women to break in and be recognised as equals. In other words, being able to put their work out there and have it treated as being equal to those of their male counterparts. So the two elements that we are going to be discussing today, named after these two great women, so Curium and Meitnerium. Both of these elements we could have put in episode 9 back when we did berkelium and all of the heavy elements, because these are part of that set. But we didn't want to, simply because these two elements are the only elements on the periodic table that are named after women.
Let's look at them in the order they appear on the periodic table, and we'll talk about the chemical elements first and then about the people they're named after. So Curium first. And of course, Pierre and Marie Curie are really, I suppose you'd call them the first couple of radioactivity. So the name actually honours them both, doesn't it?
It does, yes. So Curium was named after Marie and Pierre Curie. Chemical symbol Cm, element 96, puts it right at the bottom of the periodic table, pretty much in the middle. And it sits between americium, which we have talked about, and berkelium, which we had an episode about. And it sits in that block of two rows at the very bottom of the table, and it is one of the actinoid elements. So that's the bottom block of those two strangely positioned blocks. What about curium? Well, again, it's a transuranium element, which means that it is synthetic. It also means that it's radioactive. It was discovered in 1944 as a result, I guess, of the Second World War. And it was obtained as a result of irradiation of either uranium or plutonium in a nuclear reactor. And we can, in fact, make decent quantities of curium. So what we find is that you can extract it from spent nuclear fuel, and every tonne of that gives you around about 20 grams of curium. It is highly radioactive, so the curium is responsible, I guess, for the high radioactivity of spent nuclear fuel and nuclear wastes. We've already talked about curium's neighbour americium in Elemental, and that was element 95. And the team that discovered both americium and curium, and that was led by Glenn Seaborg, famous Nobel laureate, found it so difficult to separate these two elements from each other and also from rare earth metals that they gave them nicknames. They called them pandemonium, which is demons or hell in Greek, and delirium, which is madness in Latin.
Now, Marie Curie, she really is one of the most famous women scientists. I mean, I think if you asked almost anybody to name a woman scientist, she's the one she'd name. And she went on to win a Nobel Prize in both physics and chemistry. So she shared that 1903 physics Nobel with her husband, Pierre, and Henri Becquerel.
Indeed.
Is that how you pronounce it? The discoverer of radioactivity.
Yep.
And then she won the chemistry Nobel in 1911. Unfortunately, Pierre was already dead by then. Mm-hmm. But am I right in thinking she's the only person to have won 2 Nobel Prizes in 2 different subjects?
Well, it depends what you call a subject, because there was a very great chemist of the 20th century by the name of Linus Pauling, who also won the prize in different disciplines, let's say. He won in chemistry, and he also won for peace as well, which is a very interesting story that we may talk about later.
So tell me a bit more about her as a person.
Okay, well, she has obviously a fascinating life story, as do, I guess, many of these Nobel laureates. She was born Maria Sklodowska, forgive my Polish pronunciation there, in Warsaw in 1867. And what not a lot of people realise, and I'm certainly amongst them, was that Poland didn't exist in 1867. It was, in fact, part of Russia at the time. And there was a big nationalist movement wanting Poland to be a separate country. As a result of this, she was educated at a sort of an underground university in Poland. This was all very clandestine, and it sort of moved from place to place to keep ahead of the authorities because the Russians didn't want the Poles being educated. Her older sister then went to Paris to study to be a doctor, and basically the agreement between the two sisters was that the older sister would go to Paris and Marie, or Maria as she was then, would work in Poland and send her money to support her. And then once her sister had graduated, then she would reciprocate the favour, I guess. And so Marie eventually went to Paris and she studied chemistry, physics and maths at the University of Paris. She did very well there. She wanted to return to Poland to do further studies, but believe it or not, was denied a place at the university there because she was a woman. And probably her life would not have been the same had she gone back, because she met Pierre Curie when she stayed in Paris, and she married him in 1895, and then she started studying uranium compounds. And the reason she did that was because radioactivity had only just been discovered in 1896, and it was a whole new thing, and people were interested in how it all worked and everything. And so they were one of the first people to really start doing good research on radioactivity. And in fact, it was Marie herself who coined the term radioactivity. So what she concentrated on was an ore, a uranium ore that was called pitchblende. And those of you who remember right back to episode 1 of Elemental will know that actinium was also extracted from pitchblende. And the reason that she was interested in this mineral was because it exhibited a greater radioactivity than pure uranium. And so they thought to themselves, okay, well, if there's more radioactivity coming out of this stuff, there must be more elements in there. There must be more radioactive elements than just uranium. And so they worked and they worked and they slaved away. They really, really did. They started with 1 ton of pitchblende, and they ended up with a few milligrams of radium, and they also discovered polonium as well. Polonium named after Poland, her home country. And they isolated pure radium. They never did isolate pure polonium. And they ended up getting the Nobel Prize in 1903 for that.
Now, Pierre died in an accident in 1906.
Yeah.
But Marie continued to be a real scientific powerhouse, didn't she?
She did indeed. Yeah, Pierre died really tragically in a traffic accident, and he was run over, I think, by a horse-drawn carriage. And it has been thought that he was already suffering the effects of exposure to radiation. And remember, they didn't know that radiation was bad for you in those days. But following his death, Marie kept on going, and she was active in much more than just science. So when World War I came along, she got involved setting up a whole bunch of mobile X-ray units that went out close to the front, which is a very brave thing to do, I think. And these mobile X-ray units were in fact called Petites Curies, little Curies in French. Now, quite amazingly, her daughter also won the Nobel Prize, Irène Joliot-Curie. She won the Nobel Prize in Chemistry in 1935, which sadly was the year after her mother died. And again, it's thought that Marie died at an early age, again, due to exposure to too much radiation. And evidence of the amount of radiation that she must have been exposed to is given in the fact that her laboratory notebooks, which are stored in France, are still too radioactive to study if you're not wearing protective clothing. So if you want to get these out and have a look at them, you've got to suit up, which is quite incredible.
God blimey. Now, we're all familiar with Marie Curie. I hadn't heard of Lise Meitner before, so she also really had to fight for recognition in the science world, didn't she?
Indeed she did. And I think you're correct in saying that really not a lot of people had heard of her until element number 109 was named after her in 1997. So Meitnerium, and it has the chemical symbol MT. It was originally discovered in 1982, and it was discovered in an experiment that made a single atom of the stuff, one atom, which really boggles the mind. And especially 1982, how in the hell did they do it back then? I have no idea, but it's quite extraordinary that they could identify this single atom. So Meitnerium, again, a heavy element, a radioactive element. Unlike Curium, you can't make lots of it, as evidenced by the single atom synthesis. All isotopes of it are very, very short-lived, and they've all got half-lives of around about seconds at the very, very most, and so therefore we're never going to see a weighable quantity of this. Now, it was discovered in Germany, and that was quite unusual because most of the work on the transuranium elements had been done by both the Americans and the Russians. So the Germans came in 1982, discovered this stuff, and then they decided to name it Meitnerium, quote, to render justice to a victim of German racism and to credit in fairness a scientific life and work. So Lise Meitner was born in Vienna in 1878 to Jewish parents. She studied at the University of Vienna, and she was the second woman to obtain a PhD from there, and that was in 1905. And she then started working with Max Planck, a Nobel laureate, and Otto Hahn, a future Nobel laureate, and she moved to Berlin in 1912.
If she was born in 1878, she's just 10 years or so younger than Marie Curie.
Yeah.
But Marie Curie seemed to get to her sort of peak quite fast, and I get the impression it took a lot longer for Lise Meitner's career to peak. Mm-hmm. And I was curious to read that not only was she working in the same field as Marie Curie, but just like her, she worked as an X-ray nurse during the First World War.
You're right. Her fame didn't come till later in life. In 1926, she was made the first female professor of physics in Berlin. Then, obviously, the Nazis came along, unfortunately, in the 1930s. She was both a woman and a Jew, and as a Jew, she was forced to flee Nazi Germany. She didn't leave until 1938. A lot of her colleagues had got out a lot earlier than that. She surreptitiously left Germany for the Netherlands, and then she went to Sweden, where she ended up staying. So her collaborator Hahn stayed in Germany, and he was doing experiments that involved shooting neutrons at uranium, and this was in December 1938. And to his great surprise, he found the element barium amongst the products. We've already talked about barium and elemental, and he could not figure out how you could possibly get barium from uranium, from just shooting neutrons at uranium. How do you get this whole new element? He told Meitner about these weird results, and Meitner and her nephew, Otto Frisch, had to think about what must be going on there, and they came up with the idea that what must be happening is that the uranium nucleus must be splitting. And so that was the first example of nuclear fission, which is the process that powers nuclear power stations and is also responsible for the atomic bomb. And so basically Hahn did the experiment and Meitner and Frisch interpreted the experiment. And so papers about this experiment were published by all three of them in February 1939. And it's always a surprise to me that the Nobel Prizes were still given in a time of World War, but they were. And in 1944, Hahn, by himself, was awarded the Nobel Prize in chemistry.
No!
Yeah.
That's not fair.
A very, very strong case could have been made for all three of them to get the prize.
Exactly.
And nobody really knew what was going on with that. Now, the Nobel Foundation have a rule that all their deliberations are sealed for 50 years after each prize is awarded. So it took until 1994 for these papers to be read. And basically what seemed to be the case was that the Swedish committee who was deciding the prize really didn't know of Meitner's contribution, or the extent, I guess, of Meitner's contribution to this remarkable scientific result.
Oh, that's egregious. It makes my blood boil.
And again, quite remarkably, she was nominated 48 times for either the chemistry or physics Nobel Prizes between 1937 and 1948, and she never won it. Now, it bears remarkable testament to the work that she was doing. I mean, to be nominated once for a Nobel Prize would be a great honour, but 48 times. She was doing, wonderfully cutting-edge research, and unfortunately it wasn't recognised at the time.
You think about the achievements of Marie Curie and Lise Meitner, they had to work so much harder, but they still got so much less recognition.
Yes, they did. And Marie Curie, so she was the only person to win 2 Nobel Prizes in different sciences. She was the first female professor at the University of Paris, and she was the first female Nobel laureate, And despite all of these amazing achievements, she in her lifetime was not actually elected to the French Academy of Sciences. There were no women in the French Academy of Sciences until 1962, and somewhat appropriately it was actually her student Marie Pierre who discovered the element francium. She was the first female inductee into the French Academy of Sciences. Quite astonishing.
Well, francium is coming up quite soon in episode 28 of Elemental, so stick around. You can hear about francium. You can subscribe to us as a podcast at Apple Podcasts, Spotify, and all the other usual places. And we come your way twice a week, usually.
And we're also at rnz.co.nz/chemistry. We're back next time with dysprosium. But for now, it's goodbye from me, Allan Blackman.
And me, Alison Balance. Kia pai tō rā.